All right, so now we're going to look at a couple more situations with gap calcs that you might see on a test. These are a little bit tricky, and so they might put this on a board exam or something if they're trying to see how well you know this. So here's a situation. We've got, again, two beams. We're going to try to match at a certain depth down there. And you're told that this beam over here is symmetric and it's 20 centimeters wide, and this beam here is symmetric and it's 30 centimeters wide. However, what's different about this is that these two beams are each at 110 SSD. So this is a machine that is a 100 SAD machine. The isocenter is at 100 centimeters, but these two beams are set up at 110 SSD. Just to make it clear here, so it's a 100 cm SAD machine, so that's where the isocenter is somewhere up here, and we're treating a little bit of an extended distance at 110 SSD. All right, so this problem is a little bit tricky because when they tell you that the beam is 20 centimeters wide and this one is 30 centimeters wide, what you have to ask is where is that width defined? Is it on the patient's surface, or is it the collimator setting? Well, if they tell you that it's on the surface here, this is 20 centimeters. Your triangle is not going to be 20 over 100, or sorry, in this case, see, this half of this would be half of that would be 10, and then half of this one over here, this would be 15 cm here, if that's on the surface. So notice now my triangle, though, is not going to be 10 over 100, but it's going to be 10 over 110, because that is the distance here for this triangle right here. So when I am calculating this G1 and G2 over here, I'm not going to sorry, that's messy. I'm not going to use 10 over 100. I'm going to use 10 over 110. So I'll write the equations out here. So this G1, this is, again, if this 20 centimeters is defined on the surface of the patient, G1, this gap divided by the depth, that little triangle, is going to be the ratio of 10, which is right here, divided by 110, which is the SSD. And so this, let's see if I'll get my calculator out here and we'll figure, let's just say using a depth of 6 like we have been using, and we'll take 10 divided by 110 times 6, and so this on this side, this is going to be what I have there, 0.54. .54 cm, and on the other side there, we're going to have 15 divided by 110 times 6, 0.81. 81, or is it 82? Let's see. I guess we'll call it 82. So the total gap here is 0.82 plus 0.54. I should have left my calculator up, but that's going to be 1.36 in this problem. Now let's say instead that instead of the 20 centimeters being defined down at the patient's surface, it's instead defined at the collimator. So in other words, we're setting 20 centimeters on the jaws. That means that if we went down here to 100, it's going to be 10 centimeters here at the isocenter, which is 100. And then we go further 10 centimeters down to the patient's surface. It's going to be a little bit longer field down at the patient. In fact, I think if you figured it out, I think you'd get 22 centimeters on the patient here. But our jaw setting is 20. this 1/2 right here is 10 centimeters at this. But now we still have a triangle. See that here? Here's 10 divided by 100, and that's going to be similar right here. So we can still calculate our little gap there, G1. But in that case, the gap 1 divided by the depth is going to be equal to 10 over 100. So it's important to know where your field size is defined. Similarly over here, let's just write this. So if this is 30 is defined at isocenter, that's 15 up here, this is 100, and we'd have this G2, which is right here, so G2 over the depth is equal to 15 over 100. And if you remember from a previous problem, we got that our gap was going to be 1.5 cm, so a little bit more if it's defined there, defined with the field size at isocenter. So it's important to know that. I just mentioned this. Now in practicality, when I'm doing a real problem in the clinic, I always just ask what the collimator setting is, because as long as I know that, I can just use the collimator divided by 100, or half, whatever that jaw is there, divided by 100. So when I'm doing it in a clinic, I never worried about what the SSD is, because it doesn't matter. The triangle is the same whether you're up here or whether you're using this triangle. However, it's important to know that if you're given that on a test, because the answer will be different. All right, now I'm going to give you one more problem that I've seen on tests, and it's just you're probably not likely to see this in the clinic, but it's something you might see in a test. So let's say that instead of 110 SSD, we're treating at 100 SSD. So both of these fields are 100 SSD. And we're also told that your field sizes on the collimator are 30 centimeters and 20 centimeters, symmetric. But instead of having a 100 centimeter SAD machine, we've got an older machine, and it's an 80 cm SAD machine. So now, and again, we'll say we're looking at for a depth of 6. So how does that change it? Do we get, are we going to get the same answer? Now we've got, it's 100 SSD and 20 centimeters. We've done that before. But how does having an 80 centimeter SAD machine affect the answer? Well, it does affect it just because now this collimator, this one 20 centimeters, is defined here at 80 centimeters. In the old 80 centimeter SAD machines, the collimator setting was not defined at 100 like we're used to now, but it was defined at 80 centimeters. So this 20 centimeters is right here. This 10 centimeters is going to be defined here at 80. Same one over here. So we have our 15 cm here on this triangle, and this side is 80. So now our gap calculation is going to look like this. G1 over the depth is going to be equal to 10 cm divided by 80. Even though it's at 100 SSD, the collimator is defined up here. G2 over D is going to be 15 over 80. So let's figure out what those two are. So again, we'll assume our depth is 6. We're going to have 10 divided by 80 times 6. That's going to be 0.75. Put that in here. And our other one will be 15 divided by 80 times 6. is 1.125. So what is that together? Plus 0.75. So our answer now is 1.875, or 1 point. You could probably get away with 1.9 or so for your gap, but that's pretty precise. Anyway, but the point is that if you have an 80 centimeter SAD machine, again, I've only really seen this problem on a test, not in a clinic, but again, it's a nice one because they to ask on a test because they want to see if you understand these triangles. So I think if you can do all the problems I've listed here, you'll basically have this gap calc figured out for any situation that you'd come across.